Hello. Um, the stream should be running right now. Yeah. So I'm learning Rust. Um, man, I really want to listen to some music, but I don't know if YouTube will copyright it. It's 10 right now, Friday. Um, yeah, so let's do this, I guess. Um, Alt F4. It's not working. Okay, that's fine. I'm kind of sleepy, to be honest, but I really want to finish this so that I can get a job, I guess. I don't even know why I'm wearing this. I don't even know why I'm wearing this headset, but I also don't know if anybody is actually watching this right now. But I hope what all I'm doing doesn't go in vain, and I hope I still have the motivation to be doing this. If not, I don't know how I'll do it in my life. Anywho, immutable. As mentioned in this thing, this money not just gives you to write a code, take a product. Go ahead and see that. Oh yeah, I was listening to my VOD yesterday and there was like a lot of white noise. Not yesterday, today. So I don't know if I can add some noise cancelling down here. I mean, yeah, it's this one. I don't know. I'll figure it out later. I think that's not really important right now. Create a new project called this thing. Then your variables. Open the list and then replace the following code, which wouldn't compile. It won't compile because you're changing an immutable this thing. This example shows how the compiler finds errors in your program. Cannot immutable twice. In importance we get compile time errors when you type to change a variable that's designated as immutable. Because this very situation can lead to bugs if one of parts of our code operates on the assumption that a value will never change and the other part of our code changes that value. It is possible that the first part of our code won't do what it's designed to do. This causes the cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes the value only sometimes. The Rust compiler guarantees that when you state that the value wouldn't be changed, it wouldn't. So you don't have to keep track of it yourself. Your code is thus easier to reason through, but mutable can be very useful and can make your code more convenient to write. Although variables are immutable by default, you can make them mutable by adding mute in front of the variable name, as you did in chapter 2. Are we in chapter 2? We're in chapter 3. Insane. Okay. Oh, there are quizzes. Why haven't I been doing this? Which statement best describes what it means if it cannot change? Write a reason to your answer. You want to know, please, without reading the text, by opening the other tab. Okay. What keyword is used to this? It does not compile. Correct. Okay. Like immutable variable, constants are variables bounded to a name and not allowed to change, but there's a difference between constants and variables. First, you're not allowed to use the mute with constant. Constants aren't just immutable by default, they are always immutable. You can declare a constant using the const keyword instead of the let keyword, and the type of the variable must be annotated. We'll cover types and type annotations in the next section, so you don't have to worry about the details now. Just know that you must always annotate the type. Constants can be declared in any scope, including the global scope, which makes them very useful for values that many parts of the code need to know about. The last difference is that constants may be set only to a constant expression, not to the result of a value that could be only computed at runtime. Here's an example. The constant is 3 hours in a second, and its value is the set to results multiplied to 60. The compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write this value in a way easier way to understand and verify. Honestly, in real programs that I've seen, it's really hard for me to find like const in Python, at least. Like I don't see it at all, or most of the time. Most people just use variables. Right now, the way I even write my Python is I'm talking to myself. Holy shit. So alone. But the way I think I could just give one example. Silk Song. I hope I can also make a video on this. I can make a video on this. I don't even know whether I'll make a video on this that I'm saying right now. So there's that. All bounces simulation, C sharp, cache audio, drummer, text on the wall, tic tac toe. Wait, it's not here. Where is it? I can use this. No, not here. Is it the environment? I want to just show like an example of how I usually write my Python. Yeah, like here. I declare how it is, like boolean, so that when I check over here I can see what it means. I don't know whether that's crazy or not. I just take the extra time to just do that. Maybe I would have done the same thing here, but most of the time that's what I do. Anyway, let's go back to learning. I don't think anybody will actually care about that. Constants are valid for the entire time the program runs within the scope which they are declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know, such as the maximum number of points any player of a game is allowed to earn or the speed of light. Naming hard-coded values used throughout your program as constants is useful for conveying the meaning of that value to future maintainers of the code. It also helps to have only one place for your code where you need to change if the hard-coded value is needed to be updated in the future. God damn it. Which of the following statements is true between the difference of let and constant? Say a constant can only be assigned as a literal, not an expression of. Constants can be used in a global scope. Let can only be used in a function. Let's use the first one. It does compile. The output could just be 2. Incorrect. A constant. Let's just see the correct answer. Let can only be used in a function. Okay. So you can write. Okay, that makes sense. That's fine. Understandable. I think I see the reason why people use that instead, but yeah. Shadowing. As you see in the guessing game in chapter 2, you can declare a new variable with the same name as the previous variable. Roshisans. Oh my god. Say that's that variable, the first variable was shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable In effect, the second variable overshadows the first, taking any use of the first of taking any use of the variable name to itself until it is shadowed or the scope ends. We can say a variable is shadowed. We can shadow a variable by using the same name of the variable and repeating it using with the use of the let this thing. So I'm guessing right now this would be 5 changes to 6, down here will be 12, here is 6. This program first binds x to 5, then it creates a new variable by doing x repeated by itself. So the variable of x is 6, then within the variable it creates curly braces, then the third letter shadows x and creates one thing that really confuses me is that if you could do something like this, why do you do mutable in the first place? Like mute, like this particular stuff in the first place. You could just make it like this at once. What are chances? Like if I made chances not mutable, I can go down here and write let chances. Let chance equals to chance minus 1, and it should still do the same thing, right? Do you have to use the let? Oh, they're explaining it down there. Shadowing is different from marking a variable mute because we'll get a compile error if we accidentally reassign the value without using the keyword let. By using the word let, we can make transformations. Oh, okay. So even if I made this immutable over here, and I did all these calculations down here, it will still all the calculations are still done in this inner scope, but it doesn't change the main value over here. Interesting. The other difference between mute and shadowing is that it effectively creates a new variable when we use let keyword again. we can change the type of the variable but reuse the variable. And for example, let's say we'll reuse the same name variable. Let's say, for example, let's say a program asks the user to show how many spaces they want in some text by inputting the number of text. Then we want to see spaces. The first one is a string type. The second one is a variable number. Shadowing thus spares us from having to come up with two different names. Okay. However, if we try to use multifunction, it will show a compiled error. Oh, it's also, you're not also allowed to change the type. So the next one should always be equal to string. Okay, that makes sense. Let's see. Mutable x equals to mil. Let x equal to x plus 2. I think I'm wrong. This one doesn't compile. It does compile. Okay, so I was right. The answer here is 1. Because it's doing all this calculation in this inner scope. Yeah. Interesting. Data types. Unsigned in 32. Honestly, I can just speed run through the entirety of this because I already know everything about like data types. Do I know everything about data types? Let's see. I actually don't know. I've probably felt something. I have probably felt something. Correct. Wrong. Wrong. It doesn't compile. Why doesn't it compile? What do you mean it depends on the compiler mode? Okay. Back to the drawing board. Man, I am I'm so sleepy right now. Where am I? Okay, let's just end it here, and I can come back later and stream again. Oh, there's a new. No, it's the same. This is cool though. Spider-Man is cool. Uh, ending stream.